Hello, in this video we're going to be taking a look at what percentiles and critical values are. So a percentile, the notation for it is P with a number, the number is a subscript, so this is an example, P with a little 95. So what this is the 95th percentile, and what that means is that 95% of your data is to the left, and 5% is to the right. So let's take a look at this example. We're going to use the same bone density test score. Those scores are normally distributed with a mean of 0 and a standard deviation of 1. So they meet the requirements of a standard normal distribution. Find the bone density score corresponding to P sub 95, which is the 95th percentile. That is, find the bone density score that separates the bottom 95% from the top 5%. So here is a sketch of a normal curve, and so what we want to do is we want to find this value z so that the area to the left is 0.95 or 95%, and this area to the right is 5% or 0.05. So basically we want to use our standard normal distribution table. We're looking for the probability that z is less than some number, so that's the number we need to calculate, and the probability would be 0.95. So this is going to be some positive z value. So here is my table, and right now I have the negative side of the table up. I need the positive side of the table. So here's my positive z table. And what we have right now, so what we're given is we're given the probability or the area. So we're given the number that's inside of the table. So we want to look at the inside of this table and find 0.95. So it always takes me a minute to find them. So here's 0.9495, and here is 0.9505. So it's exactly halfway in between there, and there's a star right here, which means that there's some information down below. So follow that back to where it came from. So right here, and if you have an area of 0.9500, the z-score is 1.645. So that's the only time that you would use a number other than what's in the table. So if you don't find the exact number that you're looking for in the table here, you would use the number that was closest to it. Okay, so there are a few of these stars. So here's another star, and so you would follow that back. So if you have an area of 0.9950, then you would use a z-score of 2.575, but only for when there's a little star. If there's no little star, that means you would use either this number or this number, whichever one you're closest to. So just don't forget that. So our next example, use the bone density test. We have a standard normal distribution with a mean of 0 and a standard deviation of 1. Find the bone density test score that separates the bottom 2.5% and find the score that separates the top 2.5%. So 2.5% of the data being in the top, so this area in here would be 0.025, and the same with the bottom 2.5%, so this area would be 0.025. For this one, I'm going to use my table again, and so in order to calculate this, remember the total area under the curve is equal to 1, and so And this area here is 0.025, but the table always gives me less than, so my table is going to give me from this line off to the left. So in order to calculate this area, that's going to be 1 minus 0.025, and that is 0.975. So for the bottom, 2.5%, we want the probability that z is less than some number equals 0.025. So we need to look this up in the body of the table. So let's bring up our table. And I'm on the positive side, so I need to go back to the negative. And we want to find 0.025 inside the body of the table. So 0.025, so there's 256, 250 is right here. So that exact value is in our table. And go out to the outer side, it's negative 1.9. Let's go find that again. So it was right here. So negative 1.9, and this is 0, 1, 2, 3, 4, 5, 6. So, and the other nice thing about the standard normal distribution is that it is symmetric. And so you don't even really need to do any calculations in order to find the other one, because it's symmetric, and this area we're finding the bottom 2.5% and the top 2.5%. These z-scores are the same number, only the one on the left side is negative and the one on the right side is positive. So this is going to be 1.96. And so for the top 2.5%, z is positive 1.96. And so again, just so that we have some practice looking at the table, we want 0.976. And so we need the positive side this time. Remember, we had to subtract 0.025 from 1 in order to get that. So 9.75. What was it? 975? 0.975. Again, it usually takes me a minute to find these, so here it is right here. And so it's 1.90123456. Okay? And then our last one here, we want to find the value of z sub 0.025. So don't get this confused with the very first problem in this video, which was to find a percentile. This is a critical value. We'll be finding critical values a lot. The percentiles we won't be finding as often. But critical values we'll be looking up quite a bit. So in percentiles, so the example from above was p sub 95, so that's the 95th percentile. So this is the area to the right. Sorry, to the left. So you want 95% of the data to be the left, and so the area to the left would be 0.95. With a critical value, this is your area to right. So we want an area of 0.025 on the right, which is exactly what we did in the last example, and so that would be 1.96. Alright, that's it for this video. Let me know if you have any questions, and I hope you're having a wonderful day. Thanks!